In this lesson, we're going to be looking at two separate things, exponents and perfect squares. Let's focus on exponents first. Exponents is a way of writing repeated multiplication with the same number. We can rewrite the expression using exponents. For example, 2 times 2 times 2 can be written 2 to the third power. Parts of an exponential expression are the base, which is what we consider the big number, and the exponent, which is the smaller number in the top right-hand corner. And when we read an exponent, we read this particular example as x to the nth power. So my example above would be read 2 to the third power. Let's take a look at some other examples of exponents. Number 1, 6 times 6 times 6 times 6 times 6. This is repeated multiplication with the same number. So we can write it as an exponential expression. The number that's being multiplied is our base, our bigger number, and the number of times we're multiplying that number is the exponent. And in this particular example, we're multiplying it 1, 2, 3, 4, 5 times. So 5 is my exponent. So 6 times 6 times 6 times 6 times 6 can be written as 6 to the 5th power. And if we were to multiply that out, we would get 7,776. Number 2, 23 times 23. This is also an example of repeated multiplication. Even though we're only multiplying it twice, we are repeating the same number. And that number that's being multiplied is our base. So 23 would be our base. And we're multiplying it 2 times. So 2 would be my exponent. We can also read this one as 23 squared, or 23 to the second power. And 23 times 23 is 529. Number 3, we're using negative integers. So notice how there are parentheses around each negative 3. This is extremely important. Just like with the previous one, our base is negative 3, but we want to put it in parentheses just like in the original problem. And we're multiplying negative 3 4 times. So negative 3 to the 4th power. The reason the parentheses is so important is in order to get this final value. So when we multiply negative 3 times negative 3, a negative times a negative is a positive. Well, then that positive times this next negative, a positive times a negative is a negative. That negative answer times this negative gives us a final positive answer. And when we multiply 3 times 3 times 3 times 3, we get 81. So when we're using negatives with exponents, we have to be extra careful. Let's look at one more example towards the bottom. Go ahead and highlight 4 through 9. And then let's take a look at number 10. Number 10 is still repeated multiplication, but this time we're repeating a variable. That variable is still my base, and we still count how many times we multiply it. And for this example, we're multiplying a 7 times. So a to the 7th power. we can't technically multiply all these values because we don't know the value. We only know that it's a. So its value is still a to the 7th power. Number 11, x, 1x times 1x times 1x times 1x. Repeated multiplication, and what we're repeatedly multiplying is 1 over x. That's my base. And we're going to put that in parentheses since it's a fraction. I multiply that 1, 2, 3, 4 times. So it's to the 4th power, which is outside the parentheses. Now this one is a little bit different with the variable than number 10. I can separate this and make 1 to the 4th power, which is 1 times 1 times 1 times 1, which is 1, over x times x times x times x. Again, I can't multiply that like on number 10, so we leave that x to the 4th. So we want to multiply the things that we are able to. So our values that we know we can multiply. And everything else we just leave it like it is. Go ahead and highlight 12, 13, and 14. Let's take a look at our second topic, perfect squares. The square of an integer is called a perfect square. And we need to know the first 10 perfect squares. So just like we talked about with exponents, we're writing perfect squares with exponents. So 1 squared, the value of that is 1 times 1, which is 1. 2 squared is 2 times 2, which is 4. 3 squared is 3 times 3, which is 9. 4 times 4 is 16. 5 times 5 is 25, and so on. So if you notice, all of these are being squared. That's why they're called perfect squares, because we're squaring each of these numbers. The opposite of squaring the number is finding the square root. And when we find the square root, we use something called the radical sign. And you can see that pictured here. It's used to indicate the square root of x. And that x underneath the square root sign or the radical sign can be any number. Our perfect squares, x would be these specific numbers that we listed. These are our perfect squares. And these are things that we need to have memorized just like your multiplication tables. In number 15, let's look to see if we can determine which one in the list or which ones are perfect squares. 16 is a perfect square because 4 times 4 is 16. 20 is not a perfect square. There's not a number you can multiply by itself to get 20. I can multiply 4 times 5 and get 20, or 10 times 2, or 1 times 20. But I can't multiply one number times itself and get 20. 441 is a perfect square. Think about what number could you multiply by itself and get 441? You could multiply 21 times 21. 81. 81 is a perfect square. What could you multiply by itself and get 81? You could multiply 9 times 9. 225 is a perfect square. Think for a minute, what could you multiply by itself and it equal 225? You could multiply 15 times 15. 290 is not a perfect square. Although there are plenty of ways to multiply and get 290, I can't take one number and multiply it by itself to get that. 25 is a perfect square because 5 times 5 is 25. 500 is not a perfect square. 900 is a perfect square because 30 times 30 is 900. Go ahead and highlight 16, 17, 18, 19, 20, and 21. And remember, for 1 through 100, you should have these memorized. So you should know number 16 without a calculator. But for 17 through 21, you can use a calculator in the square root button. Let's take a look at estimating. So we have numbers that can be under the square root that aren't perfect squares. So when we estimate these numbers, we want to use a calculator using the radical sign and round. And these directions specifically tell us to round to the nearest tenth. So using a calculator, type in the square root of 90. You should get 9.48683298051. Rounding to the nearest tenth, so if we round to the nearest tenth, we need 2 decimal places. And then the 8 will tell the 4 to go up to a 5, which would give us a final answer of 9.5. And we don't want to say that the square root of 90 equals 9.5 because that's not true. We rounded it. It was about 9.5. So instead of a regular equal sign, we use this wavy equal sign. Number 23. Go ahead and type in your calculator the square root of 53. Again, it's not a perfect square, so we get a really long decimal. And to round to the nearest tenth, we need the 7.28. So that the 8 will tell the 2 to go up to a 3 for a final answer of 7.3. But again, it's not exactly 7.3 since we rounded, so we want to use the about equals to sign. Go ahead and highlight 24 through 27. And let's take a look at one word problem. The area of a square is 64 square inches. What is the length of one side? So this word square right here can be tricky and confusing. So we're going to go ahead and mark it out because that's just talking about the unit of measurement. So the area of a square, I'm going to draw a square, is 64. So that means when I multiply my length times my width, it equals 64. And we know that a square, all of our sides are the same. So we're trying to find what number do I multiply by itself to get 64. I know that 8 times 8 equals 64, or 8 squared equals 64. So the length of one side would be 8. Go ahead and highlight number 29, 30, and 31. And remember, if it's not a perfect square like in number 28, You can use a calculator and you can round. For example, number 29 tells you to round to the nearest tenth. So make sure you're reading and following directions completely and using a calculator when applicable.